So yesterday we ended with AB with an equal sign. By yesterday, I guess Wednesday. And then we had AB with a segment. And the segment typically had congruent to. So which one was a picture? Left or right? Left or right? Right? It was a picture. Then left was a what? It was a number. For example, I can give you a segment like this, bless you, and say this is 2 feet. So then for this one, our number would be 2, okay? For this one, I would have to give you another segment that is congruent to that one. So keep that in mind. Just a little reminder as to what we ended with. We know how to measure with the rulers. I'm not gonna worry about defining these, but let's actually apply them. Jake, let's read the instruction above number 1.
Set up absolute value expression to find the distance, then calculate.
So there's a fancy way of going with the absolute value. I'm going to take the norm, okay? So let's go on to number 2. On number 2, it says to find the measure of AB. So here's my A, here's my B. The first thing I need is to know what are the measurements of each tick mark. So if 2 to 4 goes here, then what must be right here? 3. So then it looks like every tick mark is being counted by 1s, 0.5s. Very good. So then if I were to look at it from here, we have, I'm going to skip every other. That would be 1, that would be 2, and that would be 3. So the measurement is 3. Any questions on that? So can you count from left to right? Okay, let's try 3 with the partner. Just say, hey, help me count. I struggle.
You're wrong.
It is not a whole number. If you got 6.5, give your neighbor a high five and say good job. Give your neighbor a high five and say good job. He'll learn, it's okay. Give him some time. All right, the next piece. Congruent symbolic notation has a little swing or squiggly with an equal to. And we already talked about that yesterday and also at the beginning of this notes. So if I tell you that AB, 1 tick mark, CD, 1 tick mark, that means they're both congruent to. So if I ask you to name this or conclude this, it'll be AB is congruent to. How do you want to name the other one? CD. Can you say DC? Yeah, it's fine. Okay, let's move on to segment addition postulate. Put a big star on this one. Very important. So it says segment addition. So clearly in my equation, I need an addition symbol. So I want you to figure out with the partner. How can I use the addition symbol to create an equation with the line segment given? Go.
A plus B right now.
Yes. All right, I heard some people say this. Point A plus point B equals point AC. And I was like, it says segment addition. So how many segments do I see right here? So I see the little one here. I see the bigger one here. And as a whole is 3, correct? So I'm going to go ahead and say the smaller piece, the 2 smaller pieces, AB. Ooh, that's a B. That's wonky B. AB plus BC is equal to AC. So I want to kind of be picky about this one. When you are adding, do you add pictures or do you add numbers? We add numbers. Because we're adding numbers, do I need the segment symbolic notation above it? No. Okay? So then let's actually apply that. Let's see. Royal, let's read example number 5, please. Okay, let's start with the first one. If B is between AC, what are my endpoints? A and C, very good. So let's go ahead and make that. So I'm gonna say, here's my A. How long you make it doesn't matter. Now, did I tell you specifically where to put the B? Anywhere in between. Put it closer to the A if you want, closer to the C if you want. I think I'm gonna put it closer to the A. Just because. You can put it closer to the C. It does not matter, because figure is never drawn to scale. The next piece. C is between BD. Who's my endpoints now? B and D. So that means I'm gonna hide this and go, okay, there's my B. So D must be right here. And again, how long you make it does not matter. So are the conditions satisfied so far? Okay, now let's plug in the numbers. AB is 24. And then it said BC is 11. Oh, that's figures not drawn to scale. And then CD is 15. Someone laughing at me, huh? All right. And it says to find DB. So DB will be the distance from, I think I'm gonna use a highlighter. DB will be this distance right here. So how many would that give us?
26.
Good, so I'm gonna write DB is equal to 26. So my question to you here is, on DB, do I need the segment symbolic notation? No, because I gave you a number, okay? All right, let's try example 6 with the partner then. The figure's already on there.
We needed to put this figure on. Yeah, we'll set it all to 0 to add it and then set it to 0.
Nate, are you done? Finished? Oh, very good. What'd you get for X? What'd you get for X? Good job.
X equals 3, right?
I'll go over it step by step.
I don't know. I failed in the calculus.
Why is it 5x?
5x plus 2 minus.
All right, give me a fist. What was the value of X go? 5? Did we all get 5?
Yeah.
Oh, it looks like we need some practice in algebra. Here I go. I think I want to move 3x on both sides, and I get 2x. Is that right? Oh no, I don't want to send you back to algebra. 17 minus 5 is how many? 12. And then we're going to subtract 2 on both sides, which I get 10, correct? Divided by 2. 10 divided by 2 is what? 5. But is that the answer that I'm wanting? No, because I want no. So NO is equal to how many when I plug in the 5 into this value? 20 how many? 27. So if you can do the algebra fast, that's fine. If you need to write everything out, that would be my recommendation, okay? Because we all make silly mistakes. Next page. Okay, midpoint. So midpoint means, or how many midpoints should there be in a segment? There should be exactly one, exactly in the middle. So that means these two are congruent too. So let's go ahead and say UM is congruent to MT. All right, Katie, let's read example number 7.
D is the midpoint of EF. If ED equals 4x plus 6 and DF equals 7x minus 9, find EF.
Okay. So who's my endpoint? Okay, let's go ahead and draw that EF. So here's E, here's F. So D has to be exactly in the middle. So I can notate these two are congruent too. And then it says ED is 4x plus 6. And then DF is 7x minus 9. Can I use segment addition postulate here? Can I say little part plus little part is the whole? Did I give you the whole? The whole expression is not given, right? So here's something picky about the midpoint. There's 2 different items that you can use. Put a big star on this one. And give me 2 points. Because I know we all want to say part plus part equals whole, which is fine. But for this one, I'm going to name it as the following. Half plus the other half is equal to the whole. But that does not apply on this one. Because I didn't give you the whole. But aren't these 2 halves equivalent to each other? So I could say half is equal to half. So only in the midpoint you have 2 equations. So ask yourself always, what part do I have? If the whole is given, use the first one. If the whole is not given, use the second one. Did we all put a star on your paper? Are we going to go over this one more time? Yes. Okay? So then we have half and half. So we have 4x plus 6 is 7x minus 9. So I'm going to move the 4x over, which gives me 3x. Move the negative 9 over, which is going to give us 15. Is that right? So x must be, our lucky number is 5 today. Is that what we're asking for? It says to find EF. To find EF, can I plug it into this guy and add it? Or can I plug it into the easier one and double it? That's what I would do. Try it. We'll still get the same answer. Did you get a value something in the 50s? 50 how many? Good job. Okay, what does the word segment bisector sounds like? When something's bisected, it sounds like it's what? Cut in half. That's exactly it, cut in half. Word for word, good job, if you said that. So I'm gonna write something on this one. Line L bisects segment RS. And I have to put a segment above it because I see a picture. Here is a common mistake when students see bisect. They go, this is congruent to that one, and that is congruent to the other side. It's only bisecting one thing. So here's an analogy. If I take my knife and cut my sandwich in half, are they both getting cut? The sandwich is cutting the knife also?
No.
No. So basically the L is a knife cutting the sandwich RS in half. So we know M is the midpoint. So therefore only these 2 are congruent to each other. Okay? Don't let everything be congruent to. Good? So think of your sandwich being cut. So that means RM is congruent to MS. So let's apply that then. Rex, let's read example number 8, please.
M is the midpoint of segment RT if RM equals 3x minus segment RT equals 7x minus 12. Find that.
Who's the endpoint then?
RT.
Okay, let's make it R and T. Because M is in the midpoint, do I get to choose where to put it? Nope, it's right dab in the middle. And then notate they're congruent too. So Rm is 3x minus 2. RT, the whole thing, the whole thing is 7x minus 12. All right, let's go to our formula we discussed. When the whole thing is not given, we do the second one. When the whole thing is given, we do half and half, right? So let's write on here. Half plus the other half. And I know you're going, well, that's missing. So we know this half. Can I say MT is also 3x minus 2 because they're equivalent?
Yes.
Yeah. Another half is 3x minus 2 is equal to the whole 7x minus 12. Go ahead and solve for x with the partner and find MT. Your x should be a single whole number. How many is my x? 8. Very good. But then that's not what I asked you for. So to find MT, how many? 20?
22.
Very good. All right, we're at the end. Today seems more like math. Yesterday was all vocab, like. All right, for example 9. Y'all ready? Dave, let's read.
Number 9. Suppose M is between L and N. Use the segment addition postulate to solve for the variable L. Do I have to read the
My awesome student will.
huh?
Hmm?
Oh, wait, I already read it. I already read the. You want me to read the LM equals 1/2?
I want you to read the space, the period, everything. Break, go.
LM equals 1/2x plus 2.
Space, comma, space.
Comma, space. LMN equals 3x plus 3/2 space, comma, space.
There you go.
And LN equals 5x.
And
plus
space.
2. And space LN equals 5x plus 2 space, period.
Period. And break.
And break.
Read everything. Okay. So we know our endpoint has to be where? Ln. So here's my L, here's my N. Then I have my M right here. So it says N is between Ln. So can we use segment addition postulate here? The small one plus the other small must equal the whole thing. So let's say Ln, Lm plus Mn is equal to Ln. And you're like, well, how did you know to use that? The reason gave it to me. I kind of gave it away. Do we all know what the word substitution means? Instead of Lm, we're going to substitute in the expression given. Instead of Mn, we're substituting in the expression. Same with the Ln. So let's go ahead and replace them. I'm going to go off to the side because I don't have enough room. I know I'm not going to have enough room. Half of x plus 2 plus 3x plus 3/2. I think I want to write 3/2 as, should I? 1 and 1/2? You guys okay with that? You don't have to. Is equal to 5x plus 2. And then we're basically doing algebra. So the first thing you do on the left side, what does your gut tell you to do? Combine like terms. Okay, let's write that down. Combine like terms. If you want to say add the like terms, that's fine. There's an easier single word that would satisfy combined like terms. Do y'all remember? Starts with an SIM. Simplify, very good. So either one of them, they are not doing it. Okay, let's combine like terms. Now it's very intentional. I'm a little offended. Okay, combine like terms. 3/2 x, thank you. I think we're speaking in code. Okay. Oh dear. So now that we combine like terms, we're gonna subtract on both sides, right? Now, I think I want to subtract the variable first. So how about we move this one and subtract it with the other one that's like. So what operation did I just say that was? Subtraction. You cannot abbreviate subtraction because of the word substitution as well. Property of equality. When you are doing the operation on both sides of the equation, you have to have property of equality. Otherwise, you're telling me it's happening on one side, okay? So property of equality means it's happening on both sides. So if I move that over, I'm gonna get 3.5 is equal to 1 1/2 x plus 2. So now we're gonna move what value? The 2? What operation is that again? All right, let's write it out. Can you abbreviate subtraction? Because of the what word? Substitution. And what do I need at the end? Property of equality. So when I move that over, I get 1 1/2 is equal to 1 1/2 x. And x is almost by itself. What do I do on both sides? Divide. This one you can abbreviate. And we are dividing on both sides, a property of equality. So if I divide 1 1/2 by the same number we get, 1 is equal to x. Is it normal to have x on the right side? It should be on the left. X equals 1. You can leave it like that ideally. Someone want to guess what that property is when I flip things over? There's two that there's one that majority of you guys are going to say. If I move them over, they're not reflected. But it's not reflexive, it's going to be symmetrical property, symmetric. We will look at what reflexive looks like later on, but not today.